Find the sum of 3 times 2/3 to the k power as k ranges from 0 to 4. Now it's interesting here we have k ranging from 0 to 4, whereas oftentimes it ranges from 1 to something. So we just have to be a little bit extra careful that we've got the correct term and the correct common ratio. Now for the first term, we know that this occurs when k equals 0, and so we've got 3 times 2/3 to the 0 power. Anything to the 0 is 1, so this is 3 times 1, which is 3. So the first term, or the initial term in this sequence, which we're taking a partial sum of, the fact that we're taking a sum of a bunch of terms, we're looking at a partial sum of a sequence. So the first term is equal to 3. And this is a geometric sequence because as we move from term to term, we multiply by 2/3 to get to the next one. So when k equals 1, which technically corresponds to the second term, we've got 3, the first term, times 2/3. And then when k equals 2, we multiply that by another 2/3, etc. So here, the common ratio is 2/3. And if we look at the sum that we're given, the sum of 3 times 2/3 to the k power as k ranges from 0 to 4, this is actually the fifth partial sum of a geometric sequence with first term 3 and common ratio 2/3. So we're going to use the formula for the partial sum. We've got a times 1 minus r to the fifth, because we want the fifth partial sum, all over 1 minus r. Now we know a here is 3, so we've got 3 times 1 minus 2/3 to the fifth, all over 1 minus 2/3. And once we evaluate all of this, we will know what the sum is. Now, 2/3 to the fifth power is going to be 2 to the fifth over 3 to the fifth. 2 to the fifth is 32. And 3 to the fifth, well, powers of 3 are 3, 9, 27, 81, and 243. So we've got 243, which I did in my head, but you can always use a calculator for. All over, well, 1 minus 2/3 is just 1/3. Because 1 is 3/3, 3/3 minus 2/3 is 1/3. So there we go. Now we need to do the arithmetic in the numerator up here. We can rewrite those with a common denominator. 1 is 243 243rds, then minus 32 over 243, all over 1/3. Let's see what that gives us. 243 minus 32 is 211 243rds. And we know that dividing by 1/3 is the same as multiplying by 3. So we've got 3 times 211 over 243 times another 3. Now we actually can cancel out these 3's with some of the factors of 243. Remember, 243 is 3 to the fifth power. So 243 has 5 factors of 3. If we cancel out 2 of those factors of 3, we're left with 3 of them, and 3 to the third power is 27. So in the end, we're left with 211 27ths, which is the value of that sum and our final answer.